Hi everyone, welcome to the channel Math for me and you. Let's learn maths together. Hello dear friends, I'm Sindhu Suresh. In this video, we are discussing questions 1, 2 and 3 from exercise 2.4. This is from chapter 2. Question 1. Determine which of the following polynomials has x plus 1 a factor. We can see 4 polynomials have given. We have to check which has x plus 1 a factor. We can answer this based on two theorems. They are factor theorem, remainder theorem. Already we have done videos based on these two theorems and I shall give you the link in the description box. Now we are going to check which of these 4 polynomials having x plus 1 as its factor. If x plus 1 is a factor, that means we can divide the polynomial completely. The remainder will be 0. To find the remainder, do we need to divide? No need. We don't need to divide. What we can do, we can take the linear factor, equate to 0 and find its value. Here the linear factor is x plus 1. We have to equate x plus 1 to 0. Then we get x is equal to minus 1. If p of x is the polynomial where we are going to check whether x plus 1 is a factor or not, we substitute this value for x. Then we get p of minus 1. This is the remainder. And if it is 0, we say x plus 1 is a factor of that polynomial. If we get p of minus 1 is any other number, that means x plus 1 is not a factor. So we can start from the first polynomial. We can take that polynomial as p of x. Let p of x be the first polynomial, that is x power 3 plus x square plus x plus 1. And what we have to find? We have to find p of minus 1. Every x we replace with minus 1. Then we get minus 1 power 3 plus minus 1 square plus minus 1 plus 1. If any negative number with odd power is a negative, here minus 1 power 3. 3 is odd number, so we get it is negative, and then 1 power 3 is 1, so negative 1. Any negative number with even power is positive, so here we get plus 1, then minus 1 and finally 1. Minus 1 cancel with plus 1, minus 1 cancel with plus 1. The answer is 0. That means we can say the remainder is 0. So x plus 1 is a factor of the polynomial x cube plus x square plus x plus 1. Next polynomial p of x is x power 4 plus x power 3 plus x square plus x plus 1. We have to check p of minus 1 equals 0 or not. For that, change x with minus 1. Minus 1 to the power 4 plus minus 1 to the power 3 plus minus 1 square plus minus 1 plus 1. Any negative number raised to even power is positive. That means here positive 1 plus negative 1 power 3 is negative. So we get there negative 1. Negative 1 square is positive 1. Then negative 1 and plus 1. Plus 1 negative 1 cancel. Again plus 1 minus 1 cancel. Finally we get it is equal to 1. That means p of minus 1 equals 1. So what we can say, x plus 1, is it a factor or not? No, x plus 1 is not a factor of this polynomial. Now we can check the third polynomial. P of x is equal to x power 4 plus 3x cube plus 3x square plus x plus 1. Here also we are going to find what is p of minus 1. Minus 1 to the power 4 plus 3 times minus 1 to the power 3 plus 3 times minus 1 to the power 2 plus minus 1 then plus 1. Every negative number raised to even power, positive. That means here plus 1. 3 times negative 1, because negative 1 power 3 is negative. Then we get minus 3 plus 3 times negative 1 square is plus 3. Then minus 1 and plus 1. Here we can cancel 1 with the minus 1, minus 3 and 3. Then finally what we get? We get the answer is equal to 1. So we can say here p of minus 1 is equal to 1. That means here also x plus 1 is not a factor because we are not getting p of minus 1 equals 0. Next polynomial p of x is x cube minus x square minus 2 plus root 2 times x plus root 2. What is p of minus 1? Minus 1 to the power 3 minus minus 1 power 2 minus 2 plus root 2 times minus 1 plus root 2. And minus 1 power 3. We know it is negative 1 because power is odd. Minus negative 1 power 2 is positive 1. That means it is 1. Minus, now open the bracket, minus times minus becomes plus 2 plus root 2 because minus times minus changes to plus. Then we have the other term outside bracket is root 2. Now we can simplify minus 1 and minus 1. Minus 2 plus 2 plus root 2 plus root 2. Minus 2 plus 2 we could cancel. Root 2 plus root 2 equals 2 root 2. See here, p of minus 1 is equal to 2 root 2. What do you say? X plus 1 is a factor or not? No, x plus 1 is not a factor of this polynomial. Second question. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. You can see p of x and corresponding g of x given in 3 cases. We have to use factor theorem and check whether g of x is a factor or not. According to factor theorem, we can take g of x equate to 0. Then we get a value for x. Substitute in p of x and find p of that value. If we get the remainder, the answer is 0, we can say g of x is a factor. If we get any other number, we say g of x is not a factor. Consider the first polynomial p of x and corresponding g of x. First of all, we will take g of x, the linear factor, equate to 0. From here, find the x value. X plus 1 equals 0 means x is equal to minus 1. Once we get the x value, we can substitute in the given polynomial p of x. Then we can find what is p of that value. Here x equals minus 1 we are getting. So we are going to find what is p of minus 1. Substitute minus 1 in place of x. 2 times minus 1 power 3 plus minus 1 to the power 2 minus 2 times minus 1 minus 1. As we know, negative number raised to odd power is negative. Here we get 2 times negative 1, that is minus 2. Plus negative number raised to even power is positive. So we get here positive 1. Minus 2 times minus 1 is positive 2. Then minus 1. Minus 2 plus 2 we could cancel. 1 and minus 1 cancel. The answer is 0. This means the remainder is 0. That means when we divide the polynomial with x plus 1, we are getting the remainder 0. So x plus 1 is a factor of p of x. G of x is a factor of p of x. Next polynomial p of x is x cube plus 3x square plus 3x plus 1 and corresponding g of x is x plus 2. Here also we have to take g of x and equate to 0. That is x plus 2 equals 0. Then we will get what is x. Here we get x equals minus 2. Substitute this value in p of x. Then we will get p of minus 2. This is equal to minus 2 power 3 plus 3 times minus 2 square plus 3 times minus 2 plus 1. Any negative number raised to odd power is negative. Here negative 2 power 3 is negative 8. 2 power 3 is 8. Plus 3 times, here we get negative 2 to the power 2. Negative number raised to even power is positive. So we get 2 square is positive 4. Plus 3 times minus 2 is minus 6. Then plus 1. Simplify the bracket. Minus 8, same as it is. Plus 3 times 4 is 12. Minus 6 plus 1. Minus 8 and minus 6 together minus 14. 12 plus 1, 13. So we get minus 14 plus 13 is minus 1. P of minus 2 is minus 1. The remainder is minus 1. That means we can say here the g of x is not a factor of p of x. Okay, next we can see p of x and g of x. First of all, we will consider g of x equate to 0. X minus 3 equals 0 means we get x equals 3. Substitute this value in p of x so that we will get p of 3. In place of x, we can put 3 and get value of p of 3. 3 cube minus 4 times 3 square plus 3 plus 6. Simplify and get the answer. 3 cube is 27 minus 4 times 3 square is 9. So 4 times 9 is 36. Plus 3 plus 6 is 9. Then positive values we can take first. 27 plus 9, it is 36. Then minus 36. What answer we get? 0. P of 3 we are getting the answer as 0. That means we can say here g of x equals x minus 3, the polynomial, is a factor of p of x, because when we put the value p of 3, we get the remainder 0. Question 3 is, find the value of k if x minus 1 is a factor of p of x in each of the following cases. We can see here 4 polynomials given, and there is an unknown value k. We have to calculate the value of k. Also, it's given x minus 1 is a factor. Given x minus 1 is a factor, what do you understand from here? We can take this factor, equate to 0, and then we get a value of x. What is that value? X minus 1 equals 0 means we get x is equal to positive 1. Substitute this value in each of the polynomials. What answer we get? Since x minus 1 is a factor, p of 1, if we substitute this value in the polynomial, this is equal to 0 we get, the remainder 0. So we get p of 1 equals 0. Now we are going to find the value of k in each of the 4 polynomials. Consider the first polynomial p of x equals x square plus x plus k. And it's given x minus 1 is a factor, so p of 1 equals 0. And every x now we are going to change with the number 1. What we get? 1 square plus 1 plus k is equal to 0. Then 1 square is 1 plus 1 is 2. Then 2 plus k equals 0. K we keep on the left side. We can move the number 2 to the other side. So we get k is equal to minus 2. Now we consider the second polynomial p of x equals 2x square plus kx plus root 2. Here also p of 1 equals 0. Why? Because x minus 1 is a factor. Now we can substitute 1 and find the value of p of 1. 2 times 1 square plus k times 1 plus root 2 is equal to 0. 2 times 1 square is 2 plus k times 1 is k plus root 2 equal 0. We want to get the value of k. So we can keep k on the left side. Move the other numbers to the right side. That becomes minus 2 minus root 2. We can take minus as common factor. Minus, then bracket 2 plus root 2. This is the value of k. K is equal to minus times 2 plus root 2. Next polynomial p of x is kx square minus root 2x plus 1. Here also p of 1 is equal to 0 because x minus 1 is a factor. And now we can find what is p of 1. Change every x with the number 1. K times 1 square minus root 2 times 1 plus 1 is equal to 0. K times 1 square means it is k minus root 2 times 1 is root 2 plus 1 is equal to 0. Now we keep k on the left side and move minus root 2 to the other side. It becomes plus root 2 and plus 1 to the other side. It becomes minus 1. So we get what is k? K is equal to root 2 minus 1. Last polynomial p of x is equal to k square minus 3x plus k, and here also p of 1 equals 0 because we know x minus 1 is a factor of this polynomial also, and then we can find what is p of 1 by changing every x with the number 1. We get k times 1 square minus 3 times 1 plus k equals 0. K times 1 square is k minus 3 times 1 is 3 plus k equals 0. K plus k we can combine and write 2k minus 3 we can move to the other side, it becomes plus 3. So we get 2k equals 3. What about k? K equals 3 divided by 2, 3 over 2. And this is the value of k. If the content in the video is clear to you, please like, share and subscribe to my channel. See you with more useful videos. Thank you.